Hi everyone, I'm David Pike, the Connector Geek, and I'm here today to talk to a couple of guys from Samtec about high-speed data cables. Now, with the latest innovations in high-speed communication technology, everything like this is very much in the news, and the need for reliable, high-speed connectivity is vital to make all this technology work. Applications including smart factory, autonomous vehicles, and the growth of both AI and edge computing are all driving the need for these new solutions. And we're going to talk today a little bit about the communications and specifically about how the transmission medium itself plays a key role in signal integrity. So I'm going to introduce you to Andy Shrout and Keith Guetig from Samtec over in the US, and they're going to talk to us a little bit about these technologies. Welcome, guys.
Hey.
Hello.
Hello.
Thanks.
Great to be here, David.
Fantastic. Brilliant to have you here. So in particular, Keith and Andy will be able to give us some details on how these cables will be vital to the kind of rocket ship speeds that we're seeing in modern telecommunications. So I'm going to launch straight into the first question and ask, I suppose the simple question is, what do you actually consider to be high speed nowadays?
Yeah, David. So high speed can mean something different to everyone, depending on the market and the applications that they are currently working on. For Samtec, high speed to Samtec at the moment is related to 112 gigabit per second PAM4 data rates. And those are the type of products that we are delivering to our customers today. And we're already looking forward to the next generation of high data rates, looking at 224 gigabit per second.
And so just to be clear, we're talking about this data rate down a single channel.
That is correct. Yes, that would be per channel, per lane. Yes.
How can such high frequencies be used in electronics for signals? I mean, you mentioned PAM4. Can we just explain a little bit what PAM4 means and how that fits into the scheme of things here?
When we're talking about PAM4 modulation and what frequencies these high-speed products would operate at, for 112 gig PAM4, we are referring to a Nyquist frequency of 28 gigahertz. And then as we are looking forward to 224 gigabit per second PAM4 operation, we are speaking about a Nyquist frequency of 56 gigahertz. So these products are performing at extremely high signal frequencies, and this is where we have to implement Samtec's latest and greatest high-speed product solutions. And just going a little bit more into where Samtec is investing in high-speed product solutions, we're not only looking at better twin ax cables or just better connector makeup. We're also heavily invested in new material sciences, looking for the best dielectrics that we can use. We are looking for different lossy materials that we can use in the structure of the connector itself to ensure that we are transmitting the cleanest signal possible with the lowest loss and the tightest impedance control over that interconnect solution.
And what sort of applications are we seeing for these kind of high-speed signals?
Yeah, so the biggest drivers in the market today for these high-speed signals would of course be high-performance computing, the supercomputers that are simulating some of these extremely sophisticated models. We are also looking at artificial intelligence. We are looking at the launch of 5G network communications infrastructure, where we need products to be performing at an extremely high level out on the edge. And so those are just some of the big drivers that we are seeing today driving these extremely high frequency signals.
When we're talking about cables, because obviously cables are going to be necessary for this, what factors are affecting the ability of signals to operate at the high speed, especially down these cables we're going to be talking about?
Yeah, so on the cable front, and really both the cable and the connector front with high-speed signaling, it really just it all comes down to the basic geometry of the product, and then of course the material selection that's used. So it's the dielectric constant in the case of a cable that is surrounding what is typically a differential pair within a twin ax, And so that dielectric constant is highly critical. Of course, the tuning of the distance from one center conductor to another, and then the center conductors to the shielding and the shielding effectiveness of the twinax, those all play a role in basically the ability to operate at a very high speed. Because ultimately, what we're trying to achieve is an impedance match through the cable and the connector. And we're trying to do that in a way to where we are mitigating crosstalk as much as possible, because crosstalk is absolutely what adds the most noise to a differential pair signaling scheme. And so when we're at 56, 112, 224 gig, it really comes down to mitigating crosstalk as one of the most dominant factors.
And we're talking about cables here, but everybody's familiar with printed circuit boards, PCBs. They've dominated the electronic market for a long time. Is there a reason we're specifically talking about cables here, or can we use PCBs for these high-speed signals?
Yeah, so the industry is getting really creative at being able to basically stretch out the runway as much in terms of what we're able to use PCBs for in terms of high-speed signaling. Now, of course, there's an inherent advantage with cabling to where you can have this perfect shielding that is surrounding the perimeter of the signaling, whereas with PCBs, it's a bit trickier to do that. You can do that with ground planes and other methods, but you don't have that perfect perimeter shielding that you have with cable. However, there's a lot of debate in the industry on whether or not we'll be able to achieve 224 gig signaling on PCBs. But as Andy and I both recall, the same sort of debate was happening at 112 gig, say 3 or 4 years ago, and so 112 gig signaling has been achieved on PCBs as well. So there'll probably be a bit more the performance budget potentially allotted to crosstalk, potentially taking away some performance budget margin from somewhere else in order to achieve continued high-speed signaling on the PCB.
So the use of PCBs in high-speed signal isn't dead yet, but as you say, the physical design of the cable just means it can be optimized for these high-speed signals.
Yes, exactly. And basically, what it does is it grows the market for cable, really, because where it's not, like you said, it's not dead yet on the PCB. There'll be a lot more incentive to reduce the amount of signaling on a PCB and transfer that signaling into cable.
One of the things we haven't touched upon yet is signal integrity, which is vital to high-speed data signals. And I know that Samtec is a world leader when it comes to signal integrity. Can you just give us an idea of what signal integrity is and how it's important to these signals?
Yeah, so, wow, that's a good question. Signal integrity is basically, fundamentally, it's more signal and less noise. That's what it is. And so basically, within any sort of signal transmission, the more that you have to dedicate a portion of your system to dealing with crosstalk, to dealing with noise within a signal, then really the less efficient that system is in terms of carrying high-speed signals. So the more pure signal that we can assist in transmitting through an application, the more that application can really be efficiently functioning at a very high speed without having to, with less components that are dealing with noise.
Okay. I've got to say that's about the clearest explanation of signal integrity I've had for however long I've been doing this. That is fundamentally, it comes down to the point of what it does. Now, so here's the key leading question when we're talking about Samtec solutions here. What is it that Samtec are doing to maintain signal integrity that allows these data speeds to be used by customers?
Yeah, thanks for that question, David. So Samtec is investing uh, a lot of engineering time and collateral into solving these signal integrity challenges that we're seeing in the market today. One of the biggest areas where Samtec is looking to solve this challenge is with our flyover cable systems. We are looking to provide our customers with um, unique solutions that really break the mold of how design engineers can architect their system and transmit their high speed signals from their ASICs or chips out to the front panel or out to their backplane. And our flyover cables is really a big integral solution to help solve those challenges.
Okay, and so we're talking about, again, it's moving away from the PCB. It's using cabling to connect directly from the silicon to the IOs. Am I getting that right?
Yeah, so diving further into flyover cable technology, it is looking to use a very tightly impedance controlled medium to transmit the signals over cable versus routing those signals, those same high speed signals, down through the BGA of the chip into the multi-layer PCB and through many inches of traces, typically where they would also need some type of component such as a retimer or redriver to help clean up that signal along the path to get to either the front panel or their backplane. By using flyover cable, they can omit the need for any additional circuitry or advanced equalization techniques. They can simply place a Samtec interconnect either as close to the chip as possible, what we would call ASIC adjacent, or we're even looking at putting those same cable interconnects directly onto the chip package. And that way we can transmit those signals directly to the package, again, to the front panel or to the back plane over a decent amount of cable length, potentially up to 20 inches of cable, which allows an architect to place that ASIC in a very strategic location within their system and use the cable to make up that longer length difference to the front panel or to the back plane.
So that's really interesting because that provides all sorts of different methods to include efficiency. It's not just about preserving the signal, but we're talking about reducing the number of components that might be needed. We're talking about the ability to put the ASICs in, as you said, strategic places, but they can be put in the optimal location for things like thermal management and other communications. This is really interesting. The fact that these high speed cables are allowing other benefits, not just the preservation of high speed signals. It's about the ability to design a system in a more optimal way.
Yes, absolutely. And you touched on a very big challenge beyond the signal integrity, thermal management. You mentioned thermal management. This is a huge challenge to overcome in these next generation systems. Of course, as we look to generate higher speeds, that's also going to require more power, and with more power comes more heat. And so thermal management is critical to the success of these designs. And again, with the flyover approach, allowing that strategic placement of the ASIC, you can get it much closer to your fans or other exhaust systems that are pulling the heat out of the system. It also allows a more modular type of architecture, where instead of having one extremely large multi-layer PCB that are driving all the signals from the ASIC out to the other portions of the design, we can now break these systems into much smaller modular PCB structures where maybe they have an extremely high-speed PCB that contains the ASIC, but as they use cable to launch off that board, now they can use lower cost, more mainstream dielectric materials to do their power delivery or lower speed signal transmissions, and it provides a this modular system that just provides much more flexibility to system design. And this also helps with thermal management as they can again break their system down into smaller chunks and be more strategic on where they place everything. And I would say one aspect of using more cable within the system, initially, you might think with having more cable in a system, this is adding more mass and would provide blockages within the system that prevents airflow. But working with our customers, Samtec works very closely with our customers to model, 3D model a system, provide the layout of what the cable system should look like for optimal routing to help avoid air blockage and ensure that we have very clean and optimized routing for air and heat to exit the system. So these are things that Samtec is certainly considering and thinking about, and ensuring that we work closely with our customers to provide that full system solution, not just thinking or focusing solely on signal integrity. We're of course thinking about thermal management and everything else that has to come into play for successful system design.
That's really interesting information that we're not just talking about signals, we're talking about a whole approach to the mechanical, the thermal and the electronic design. But cables are a big part of this, and we're talking about twin-axe cable here. What is it that Samtec's doing a little bit different with twin-axe to be able to boost this performance and get the best out of these systems?
Yeah, very good question, David. Samtec does feel and know that the way that we manufacture our twin-axe provides the best optimal twin-axe solution in the market today. What really sets Samtec apart from all of our competition or any other cable manufacturer is the fact that we have been implementing a co-extruded dielectric technology ever since day one of fabricating our own twin-axe. And this is a big point because Samtec is fully vertically integrated on all of our raw cable fabrication. So we manufacture our co-extruded ultra-low skew twin-axe, micro coax, precision microwave RF coax, as well as some power cables. So we have a lot of knowledge, a lot of years of service within our cable plant that provides the optimal solution. And I'm going to go back to our co-extruded dielectric technology. This is where we are extruding both center conductors that make up the twin-axe simultaneously into a common dielectric. There are many advantages of this. First off, being that we can provide the lowest interpair skew in the market today over our co-extruded twin-axe. As Keith mentioned previously, crosstalk is a critical aspect of any signal integrity, but also when it comes to differential pair, we need extremely close coupling between the positive and negative signal within that pair. And by having the lowest interpair skew in the market, we're able to provide the cleanest channel for high-speed differential pairs. Beyond the co-extruded dielectric, we're also implementing the latest shielding technologies within our twin-axe cable. We are typically doing 2 layers of shielding to provide the lowest signal-to-noise ratio. And this also provides an extremely tightly controlled impedance medium to hold the signals extremely clean and to get the lowest loss possible from point A to point B. So those are just some few of the advantages using Samtec twin-axe. I could keep going on and on with the just the overall abilities of our twin-axe, but no doubt it is a very high-performing solution to meet the challenges of 112 gig and the future of 224 gigabit per second data rates as well.
It's fascinating to know that the actual construction of the cable is playing as much a part in the transmission of the signals as the connector ends and the preparation of the cable as well. But I suppose there's an elephant in the room. There's a question that comes along, and we've been talking about fiber optics for years and years and years. These are still copper solutions, and I've heard in the past that copper's going to die and fiber's going to take over because only fiber can cope with these really high data rates. But that's clearly not true. Samtec's doing some fascinating things with copper, but fiber is still an option. So where does copper stop and fiber take over?
Great question, David. I can help with that one. And so there's a simple, straightforward answer, and then there's a less straightforward one. So today, uh, that the point where copper stops and optics begins, it's predicated on length. And say at a 112 gig with PAM4 modulation, that length is approximately around 3 meters. In terms of where you get beyond 3 meters, then more likely you're putting yourself more in optics land. The less straightforward answer is that today it's not that like is copper gaining in terms of usage in the market, or is optics gaining? Today, it's more copper and more optics is what we're seeing. The growth within our optical products and the growth within our both copper connector products and copper cabling products, all of those product families are growing in a tremendous way. And really, the big umbrella for that is something that Samtec refers to as our current age being of a technical renaissance. A technical renaissance in terms of it's a overlaying of catalyst in terms of, and then eventual 6G, AI, machine learning, which you mentioned a moment ago, Auto 2.0. This technical renaissance, it's bringing upon new applications, brand new industries, brand new emerging markets, and a common thread across all of these new applications and markets is the need for high-speed connectivity. And so high-speed connectivity requires both copper and optics. And so we're seeing just tremendous growth for both.
That's really interesting that it isn't a case that copper will eventually go away and be taken over by fibre. There is clearly a place in the market for both technologies, and what's interesting and heartening is that both technologies are growing, because there's all these new applications out there, some of which are with us already, some of which we're talking about for the near future. So it's fascinating. Now, from the point of view of Samtec, what is Samtec doing in the fibre world to go alongside the copper that we've already talked about?
Sure. So similar to twin-ax cable vertical integration that Andy was referencing a moment ago, we're also vertically integrated within our embedded optics products. So our primary driving platform in the market is our Firefly platform. The Firefly platform is focused on embedded midboard optics, and that's where Samtec differentiates. Where there is a much bigger, broader market for active optical cables that are high-speed I/O at the port. We've really focused on applications that can benefit from the optics being basically adjacent or very in close proximity to the chip package on the host board of the application. Much shorter copper signaling there, and we're seeing applications that can benefit from embedded optics as opposed to AOCs. We're seeing a lot of growth there with embedded optics. So what Firefly delivers ultimately is aggregate data rate density, meaning the most data rate that you can get within a square inch or a square centimeter on a PCB. That is the value that we're delivering. And plus, we can do that at many different data rates, many different modulation schemes. We've got just all kinds of different line extensions where we can cater our Firefly platform specific to a given application.
This has been fantastic stuff, and I hope everybody watching will get a feel for not just the application in terms of high-speed signals, but the kind of solutions that Samtec is able to offer and the benefits it brings. As I say, not just in terms of transmitting data at a particular rate, but from what both Andy and Keith were saying, in the way that the whole system can be designed, the architecture of the system, which is bringing advantages for not just signal integrity, but also for thermal management, for mechanical design, and for efficiency overall. So I just want to say a huge thank you to Andy and Keith for giving me an overview of this fascinating technology. I wasn't expecting to learn as much as I did about things like the thermal management and the mechanical design. And so it's been hugely useful for me. I hope everyone here will take away some interesting information from this. If you need more information, obviously the Samtec website, samtec.com, has got tons of information about all of the products that we've talked about today, the products themselves and the technology that goes behind it. There are all sorts of interesting simulation tools on the Samtec website that allows you to start planning these designs before you ever actually have to buy a connector itself. There's some fascinating technical marketing tools that are available on samtec.com. So I think the best thing for me to do is to say a big thank you to Andy and Keith for your time today and for giving us all this information, and for, incidentally, possibly the best explanation of what signal integrity is that I've ever heard. So thank you to you both. It's been great to talk to you.
Yeah, my pleasure, David.
Thanks, David. Yeah, happy to be here.
Fantastic. Thank you for watching, and hopefully we'll see you again soon.